Okay, so day one, let's take a look at this. Well, let's pay attention now because the final is just around the corner. We have one more test on polynomials, okay? And then we have the finals coming up. I believe it's all going to be on paper. There's multiple choice, and that might be on the computer. I'm not sure. How many would... No. Because there's two parts to it. How many of you would prefer to do it on paper versus computer?
They just want to cheat.
Yeah. Jeffrey, question?
Shut up.
Can you give me the definition of polynomial?
A polynomial is a poly means many terms, kind of, many terms, but we will get into that in just a little bit. All right, so, Rihanna, lovely singing. Let's not do it now. Huh? All right, should we complain a little more and then say enough with everything and then we can start? Okay. No more complaining, no more good things, no more complaining. Daylin, please put your backpack down. Thank you. All right, so in simplifying, these are two expressions that are being multiplied together. So to begin, you put the coefficients out front and say those are kind of like similar terms. 2 times 3. Then I'm going to pull out front my variables. X to the first, if there's no exponent on it, put a 1 on it. And x to the second. And then I also have y to the third and y to the second. 2 times 3 is 6. X to the first times x to the first. When you have two powers that you're multiplying that have the same base, you keep the base. And what do I do with those exponents? Add. Yes. So this becomes x to the third. And I do the same thing for my y's. They have the same base. I keep the base and add the exponent. So this becomes y to the fifth. So final answer is 6 x to the third, y to the fifth. Anybody have that? Good. If you did not, do you understand how to do it now? Tristan, please put that away. All right. So number 2, this time we have a product of an expression taken to a power. Product just means we're multiplying. Everything in here is taken to the second power. Even the 4, which doesn't have an exponent, so I'm going to put a 1 on it. Okay? The 2 then gets distributed or multiplied with everything on the inside. Tinder, put that up, please. So that is 4 to the 1 times 2, m to the 0 times 2, and n to the 3 times 2. So this becomes 4 to the second, m to the 0, because 0 times 2 is 0, and n to the 6th. So we do. And it's not the 0 that becomes the 1, it's the whole power. So m to the 0, that whole thing becomes a 1. All right? So that's just multiplying by 1, so it really doesn't change anything. 4 squared, n to the 6th power. Is that in simplest form? No, you can simplify 4 squared. Is that 8? 4 times 2? It's 16. Yes, 4 squared means 4 times 4. So the final answer here is 16 n to the 6th power. Did anybody happen to have that? Okay, a few. Good. Now, if some of you were saying up here, why didn't she take m to the 0 power and change it to 1 there? I could have done it there also. That m to the 0, I could have changed that to a 1. And so it would have kind of just disappeared or said 1 to the 1 times 2 power is 1 squared, which is still 1. Okay? So in case you were wondering about that. Any questions about that? Now, guys, I mean to tell you, we do this together every day. Even if you just listen and copy it down and you turn it in, that should be 10, 11, or however many points these are, and it should be easy points, okay? So please take advantage of doing this when we do it together and turn it in. So many people did not turn this in. All right? Okay, now let's take out the notes packet, which has a science-y balancing scale on the front, I believe. Okay. And so we have split up this chapter on polynomials into 11A and 11B. 11A we're going to do here before the end of the semester. 11B will happen after the semester. Okay? So on the front, these are the standards that we're talking about and standards for mathematical practice. Look at this last one. Attend to precision. Do you know what that means? Attend to precision. That means you have to be very precise, very careful, very intentional when you are doing your math. You have to be careful because it's very easy to make little mistakes, okay? All right, let's go to the inside of this packet. And we are talking about a lot of definitions here. Excuse me. A lot of definitions. All right. So, trying to find my little cheat sheet. So many papers, so little time. All right, I just had it. Here it is. Okay. So, like I said, when I was asked about polynomials. Poly means many. Polygons are many-sided figures. Polynomials means many monials, many nomials. Okay? So here it says up at the top, a polynomial is a monomial or the sum of two or more monomials. Some polynomials have special names, okay? So a monomial, that's the first one. Mono, do you know what that prefix means? One. So basically, this is talking about one term, okay? So the definition is a number, a variable, or a product. Product. You know what product means? What operation? Right. Or a product of one or more variables. So a monomial, one term, number, a variable, or a product of one or more variables. Examples would be 4, which is like your number. Variable, we could say m to the 5th power. That would be your variable. And we could say like 3x. That is the product of one or more variables with the number. Okay? So monomial, one term. Then we have binomial. Bi is a prefix meaning 2. So this means 2 terms. And the definition is a sum. And sum is what operation? Addition. Sum of 2 monomials. For example, I could have x plus 3, or I could have 2x squared minus 1. So as you're looking at this from the first one, those are all monomials. 4m to the 5th, 3x. As you look at the 2 terms, they are separated by either an addition sign or a subtraction sign. So all polynomials will be separated by addition or subtraction. Okay? And finally, trinomial, you know it, our friend and yours, is going to be how many terms? 3 terms. 3 terms is the sum of, we're adding, sum of 3 monomials. So for example, x squared plus x minus 4. There are 3 terms and they're separated by addition or subtraction. Any question about monomial, binomial, trinomial? All right. So the degree of a monomial is the sum of the exponents of all its variables. Sum, meaning we are going to, ooh, I hate it when I do that. Sum, meaning we are going to add up all the exponents of just the variables. Just the variables. A non-zero constant term has a degree of 0. A non-zero constant term. So if I had the number 7, its degree would be 0. Even though we put a 1 on it, its degree is 0. And 0 itself has no degree. Okay? So that's if you just have a monomial. You add up all the exponent numbers on the variables, and that gives you its degree. However, the degree of a polynomial, when you have more than one, is the greatest degree of any term. So you have to look at all the terms and say, hey, what's the greatest of the terms that I have here? You can find the degree of a polynomial by finding the degree of each term. Polynomials are named by their degree. Okay? So if I had a degree of 4, we would call that a quartic polynomial, because quartic means 4. So let's take a look at some of these degree names down here at the bottom. If it has a degree of 0, that is a constant number. Like, oh, I always do that. Like 3 or 7 or 8. Those are all constants. If something is linear, that has a degree of 1. That could be like M. Let me do a different color. That could be like m. That could be like 5p. That could be, I could say 4t plus 2, because the linear means it has a power of 1. So this would be m to the first. This would be p to the first. This would be t to the first. And remember, this 2 would have no degree. Okay? A quadratic has a degree of 2. So that might be 1, let's do a different color. 1x squared. That could be 5q squared plus 3. Somebody knocking? No? Okay. Cubic is going to have a degree of 3. Quartic has a degree of 4. Quintic has a degree of 5. And if you get to 6 or more degrees, you just call it a 6th degree polynomial, a 7th degree. So 6 or more, you just name by the number of degrees. Thank goodness, because nobody wants to memorize all these bizarre names. Name by the number of degrees. Okay? Then it says, addition is commutative. Therefore, the terms of a polynomial can be written in any order. Commutative means you can change the order. That's how I always remember. CO and CO here. You can change the order. So if we said 3x plus 4, that's the same as 4 plus 3x. We can change the order and it still means the same thing. However, the standard form, and this is going to be important, the standard form of a polynomial has the terms written in order from greatest degree to least degree. Greatest degree to least degree. When a polynomial is in standard form, the coefficient of the first term is called the leading coefficient, but it has to be in standard form. Okay? Now, I don't know if you realize it or not, but you have just been given a vast amount of information. So it's going to take a little while to digest it all. All right? Let's take a look at the top of the next page. Let's look at some of these examples. So, identifying polynomials. Determine whether each expression is a polynomial. If it is a polynomial, find the degree and determine whether it is a monomial, binomial, or trinomial. Okay? So, as I look at this first one, I'm going to say, let's put it in standard form first. So above here, I want you to put standard form. Standard form. That just means you're going from the highest degree to the lowest degree. Okay? Standard form. So for the first one, it says 7 minus 5x squared, y to the third plus 6x. We're going to try to write it up above because there's not a lot of extra room. Which of these do you think has the largest degree or the highest degree? The first term, the second one, or the third? It's going to be the second one. So I need to take this and say negative 5 x squared y to the third plus 6x plus 7. We just put that in standard form. The type of polynomial. How many terms do you see for that polynomial? 3 terms, right? Here's 1. It's separated by addition. Here's 2, separated by another addition, 3. So a 3-termed polynomial is called a trinomial. A trinomial. The degree is the, oh shoot, I just noticed that. Standard form down here. Let's put standard form down here because we will have a lot more room. Negative 5x squared y to the third plus 6x plus 7. The degree of the whole polynomial is the degree of the term with the highest sum of the exponents. Okay? So if I look at the sum here, I've got a 2 and a 3, that it gives me a sum of 5. Here I have just a 1, and here I have 0. So that means the degree of this whole trinomial is the largest one, which is 5. Okay, so only the largest one is going to go in there. That is the degree of that polynomial. The leading coefficient is the number out in front of your polynomial. So in that case, your leading coefficient is negative 5. Okay? Any questions about that? All right, let's take a look at the second one. Do you guys have 2 terms or 3 terms in your first one? Was yours a little different from mine? Did you have 7 minus?
Yes.
Okay, good. All right, so the next one, 9x to the 5th plus 7x to the 9th minus 2. How many terms do you see there? 3, right? Separated by 2 addition signs, so that is another trinomial. Okay, let's put it in standard form. That means you look at each of these terms and find the degree with the highest. Well, here I've got a 9, here I've got a 5, and that 2 has a degree of 0. So it's going to be 7x to the 9th plus 9x to the 5th.
Why you put the 7 first?
Because it has an x to the 9th power. You want the one with the greatest degree, the greatest of all of the exponents, to go first. Good question. So 7x to the 9th plus 9x to the 5th minus 2. So what is the degree of this polynomial? Is it 9? Is it 5? Is it 0? Or is it 14? It is 9, yes. It's the largest one of all of the terms. Your leading coefficient, right here, the one that is in the lead after you've put it in standard form, is your first number, so that's 7. And the last one, how many terms is 4a squared b to the 5th c? How many terms is that? No. You got to look where it's separated by addition or subtraction. Do you see any? It's 1. So we call that a monomial. Monomial, 1 term. Standard form would be the same, 4a squared b to the 5th c. And since there's only 1 term, I need to take the degree of every power on the variables that I have. So that means I take the 2, I add 5 to it, and 1. So 2 plus 5 plus 1, because you have to add all of them for the term, makes this 8. 8th degree.
So the leading coefficient is 4.
Leading coefficient is 4. Very good. Questions about that?
Your standard form stays the same.
Yes, because there's only one term. If there was another term, we'd have to add up all of those exponents and see which one had the higher degree to go first. Okay? All right, so let's see if you can do the bottom one together on your own a little bit. It says, complete the table. So they give you an expression. First of all, is it a polynomial? What is its degree? And what is its classification? If it's not a polynomial, there is no classification. So take just 2 minutes and see if you can do that one. Are you doing okay? You can use your notes, right? Okay. I just don't know. I have them. Okay. Okay. You can use them if you want. See if you can do that on your own. Focus on the ones that you feel more comfortable with, the ones that you know.
Is it to be an exponent to be have an exponent to be considered
A polynomial? No.
a thing, like for the trinomial thing?
A trinomial?
Yeah,
Does it have to have a what?
an exponent. Like you see how this 3?
Mm-hmm.
Like I'm trying to word my question.
Okay.
Like, does it have to have like an exponent?
On all of them?
No, to
No.
be considered one.
No. Doesn't have to. If I understand your question right. Yes. Mm-hmm. Jalen, let's take that away, please. Okay, is everybody trying this? Rihanna? Honey, come on. Yeah.
What do you mean by classification?
Classification. Is it a monomial, trinomial? Is it 2 term, 1 term? All right. You might not have had total enough time, but let's start to go over these, okay? So, they did not give us a great definition, but I will tell you now, polynomials will not have any division of a variable. Okay? So the first one says 3z to the negative second. That has to do with what we just dealt with. That z to the negative second, you can't have a negative exponent. Somebody at the back door? Someone is. So this would be 1 over, or 3 over, okay. Let's wait a little bit closer to the end of this page if we can. 3 over z to the second power. 3 over z to the second power. Because that negative exponent moves it from the top part where it is down to the bottom. So that is dividing by a variable. So is that a polynomial? That's a big no. So it is not a polynomial. It is not a polynomial. Okay? So we don't even need to worry about the degree or the classification because it's not a polynomial. All right? You cannot divide by a variable. So you can't have 3 divided by z squared. Okay? What about the next one? 2x to the third plus x minus 12. Is that a polynomial? Yes. What is the degree of the whole polynomial? Even though I said the whole thing, you only look at the term with the highest amount. It is 3. And since it is, how many terms is it? No. You got a plus sign and a minus separating 3 terms, right? So it is a trinomial, yes. Good. Trinomial. Any questions on that one? Letter C, 9b, is that a polynomial? Yes, it is. What is the degree of that term? 1, yes. Remember, only the variables, when we were looking at degrees, only the variables. And the classification? Monomial. And the last one, 9x minus 2, is that a polynomial? Yes. What's the degree? 1 again. But wait, it's got 2 terms. It doesn't matter. You look at the degree for the highest term, okay? The highest number of exponents, the sum of the exponents. And that is a binomial, yes, because it has 2 terms. All right? Any questions about that table? Okay, the next one says, write 4x plus 12 plus 2x to the third minus 3x squared in standard form. So that's the first thing we need to do. Then identify the leading coefficients. We have 2 things to do here. What is my first term going to be? What has the highest degree? 2x to the third, yes. 2x to the third, that has a degree of 3. Next would be minus 3x squared. Then I have plus 4x, because there's no sign in front, I know that's positive, and then plus 12. So we have written that in standard form. And what is my leading coefficient? 2. I call that the LC. Leading coefficient is 2. Okay. So part A says, write 5b minus 10b squared plus 35 minus b to the third in standard form. So go ahead and do that in standard form. What has the highest degree? That's what you want to start with. What has the next highest degree? So which one of these terms has the highest degree? Sanaya? What has the highest degree here? Which term? B? Huh? B to the third, yes, and it's a negative b to the third because that has a degree of 3. My next one has a degree of 2, that would be negative 10b squared, plus 5b has a degree of 1, and then plus 35.
So you don't finish after you find the first one, you don't continue writing it just as the proper way you keep finding the next leading coefficient?
Somewhat. If like this, yes. But if you have multiple ones like this, then you have to be careful because maybe this will be a 1, but maybe this y would be a 5. So here, this would be the one you would start with. So it doesn't automatically go down because you have to find the sum of all the exponents. This has 6. This only has 3. So this one would start out. And then if it was just these 2, this one would be second. Okay? Does that make sense, kind of? So identify the leading coefficient. What is my leading coefficient of this right here?
Maybe 10.
What is it?
10.
No.
10.
No. Leading would be my first term.
1.
So it's going to be -1. -1. Is everybody with me? All right, so let's see. Yeah, tomorrow we're going to start to learn how to add. You do have a separate homework packet. Homework number 1. Guys, this is important. You've got to practice the homework to be able to know how to do it. Homework number 1, this is going to be due on Wednesday. You cannot do the whole thing, but you can get started on it. Okay? Homework number 1, due on Wednesday. Yes?
What did you say? You gave us a sticker.
I said, yeah, you can go now. I just said wait till we get to the end. Yeah. Jada, is that your paper on the floor in front of you by chance?